Hi, my name is Nur Syair Haja.
Hi, my name is Fitri Safia.
Hi, my name is Nur Iman Humaira.
Hi, my name is Siti Nur Nadiatul Husna.
We use elevator almost every day, but have you ever thought about how they actually work? From most the high-rise buildings, elevators are essential to modern life. But from the simple right is a complex system of mechanics.
In this case study, we will break down on how elevators work, what affect their safety, and how Newton's law help us to understand it.
Next time, when you step into the elevator, will you see it in the same way? Let's go behind the scene
And discover the mechanics that lift us up. First of all, let's explore how elevators actually work. To begin with, an elevator uses strong steel cables that are connected to a motor. These cables pull the cabin up and down. In addition, there's a counterweight that helps balance the cabin's weight, so the motor doesn't have to work as hard. Moreover, the elevator moves smoothly along rails, and there's a control system that ensures the elevators stop at the right floor and run safely. Elevators are especially important in large buildings such as hospitals, where they are used to quickly and safely move both people and equipment. This system is designed to be both safe and energy efficient, which is essential in such high-demand environments. In summary, elevators are a crucial part of modern buildings. Their clever design and mechanics help us move between floors easily, safely, and efficiently. Now, let's talk about why we use elevators and how they make our daily life easier. To begin with, elevators help save us both time and energy. They are much faster than taking the stairs, especially in tall buildings. Additionally, using an elevator is far less tiring where you need to travel up many floors. Next, elevators provide a crucial level of accessibility. They are particularly helpful for elderly individuals, pregnant women, or anyone who faces mobility challenges. In this way, they ensure that everyone can move around the building with ease and comfort. Another reason we use elevators is that they make it much easier to carry heavy items. For instance, boxes, luggage, and equipment can all be transported effortlessly by simply taking the elevators instead of trying to manage stairs. Furthermore, elevators provide safety and comfort, especially during emergencies or on hot days. When you need to avoid long walk or heavy exertion, elevators offer a quick, convenient, and a safe way to get between floors. In conclusion, elevators not only save us time and energy, but also make it easier to transport heavy items, assist those with mobility issues, and keep us comfortable and safe in a variety of situations.
So what we will learn throughout this case study is we get to know the forces and energy in an elevator. So we also get to know how counterweights help to save energy, how to calculate power needed for lifting, and the real-life importance of mechanics in elevators. The hospital elevator 550 kg carries the patient 80 kg, 2 nurses 75 kg for each, and a medical machine 30 kg, moving upward 12 meter and 1.8 meter per second. So it uses a counterweight equal to 40% of the total loaded mass and is driven by a motor through a steel cable. So we assuming no friction gravity equals to 9.8 meter per second.
First, we need to calculate the total loaded mass of the lift. We have the lift's own mass 550 kg, one child is 80 kg, 2 adults 75 kg each, and a wheelchair 30 kg. So the total is 550
plus 80 plus 150 plus 30 plus equal to 810 kg. Next, the system uses a counterweight that balances 40% of this total mass. So, counterweight 0.40 because it is 40% multiplied with 810 equal to 324 kg. This means the effective mass that the motor actually needs to lift is 810 minus 324 equal to 486 kg. Now, let's calculate the tension in the cable. Since the lift moves outward at constant speed, acceleration A equal to 0. So the force needed is just due to gravity, which the formula tension T equals to mass multiply G. We get 496 multiplied 9.81 equal to 4,767.66 Newton. Then the mechanical power required is calculated using power equal to force minus velocity. With velocity V equal to 1.8 meter per second, power is 4,767.66 multiplied with 1.8, we get 8,581.79 watt. So the system requires around 8.58 kilowatt to move the lift at constant speed. Now, let's explore what happens if we increase the counterweight to 66%. New counterweight mass 0.60 multiplied with 810 we get 486 kg. The new effective load becomes 810 minus 486 we get 324 kg. Then, the new tension is 324 multiplied with 9.81 we get 3,179.64 Newton. The new mechanical power 3,179.64 multiplied with 1.8 we get 5,723.35 watt. So with the heavier counterweight, the power required drops significantly. Finally, to find electrical power needed, we account for motor efficiency of 85%. So P electrical equal to 5,723.35 divided by 0.85, we get 6,739.25 watt. That's about 6.74 kilowatt, which is lower than before.
Discussion. The study looks at how much force and energy are needed to operate a hospital elevator safely while carrying people and equipment. The goal is to calculate the total weight, cable tension, and the power needed to move the elevator at a steady speed. We also explore how using a counterweight helps reduce the energy used by the motor. This is important because elevators are used every day in hospitals, offices, and apartments. Knowing how much energy is needed helps engineers design safer and more efficient systems. In real life, this can reduce electricity bills, prevent motor overload, and improve safety for patients and staff. For conclusion, in this study, we explore how much force and energy a hospital elevators need to safely carry people and equipment. We found that using a counterweight reduces the load and saves energy, making the elevator work more efficiently. This is important because elevators are part of everyday life in hospitals, office, and home. Understanding the mechanics behind how elevators work helps us design safer systems, save electricity, and reduce costs. This shows how learning mechanics is useful in real life to solve problems and improve the technology we use every day.